This is my intermediate algebra course. Today we're going to prepare for the first test of the course. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. There are some subjects where you can study the night before and ace the test. Math doesn't work that way. You need at least 2 days to prepare for a math exam, and that's the absolute minimum. Really, you should be spending probably 3 or 4 days if you really want to prove that you know this material. But it doesn't matter how many times you tell students to study for a test, they're not going to do it. So in order to force you to do at least some studying, we're going to do a practice test right now together, and I'm going to give you a practice test for homework. And these practice tests are not only going to force you to do at least some studying, but they're going to familiarize you with the format of the test. Now, these tests are not going to guarantee that you get an A or a B on the actual test, but hopefully they'll ensure that you at least pass. Now, like all my tests, this exam has 25 questions, and each question is worth 4 points for a total of 100 points. Now, as we go along this test, I want you to attempt each problem on your own before watching me do it. That's going to give you a lot more information. For example, if you attempt this first problem and you can't do it, that gives you very valuable information. It tells you what you need to study to prepare for the exam. Do not take the exam without first finishing these 2 practice tests. So go ahead and take do problem number 1. And if you get stuck, that's okay. I would be surprised if students didn't get stuck on some of these problems because you may be a little rusty. We haven't looked at this stuff in a couple weeks. So if you get stuck, that's okay. We'll do it together, but I want you to at least attempt the problem first. So try number 1. When you come back, we'll do it together. Okay, we're back. Now, this first inequality is in slope-intercept form. We have y equals mx plus b. So b is the y-intercept, where the line crosses the y-axis, and m, which in this case is 1, is the slope. So when we graph lines in slope-intercept form, we start with the y-intercept, which is 0, 2. And then we use the slope, which is 1. Now, if the slope is 1, we can write that as 1 over 1, which means move up 1 and to the right 1. Up 1 and to the right 1. So we start with our y-intercept and go up 1 to the right 1. Up 1 to the right 1. Remember, the slope is described as the rise over run. Now notice that it says y is less than x plus 2. It does not say less than or equal to. So what that means is we're going to have a dotted line. Okay, now let's graph the second inequality. It just so happens that the second inequality is in point-slope form. Be aware that you may get a problem that's in standard form. Those are the 3 forms: slope-intercept, point-slope, and standard, which is ax plus by is equal to c. So in point-slope form, we have y minus the y value of a point on the line we're trying to graph is less than or equal to the slope, which is negative 2, times x minus the x value of the point on the graph or the line we're trying to graph. So what that means is that we have a point on the line which is negative 3, 1. Now notice I changed the signs. It's not positive 3, it's negative 3. It's not negative 1, it's positive 1. That's just the way it works when you're using point-slope form. So now let's graph that point. Negative 3, 1 is there. I'm going to use a different color. And notice it says less than or equal to. That means we're going to have a solid line. And the slope is -2. So if the slope is -2, we can write that as -2 over 1. So what that means is we're going to go down 2 and over 1. Why down? Well, because it's negative. Down 2 over 1, down 2 over 1. Then when we go in the other direction, we go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1. Now again, it's going to be a solid line because the inequality symbol is less than or equal to. Okay, so now what we're going to do is we're going to shade in this region, or we might shade in this region, or this region, or this region. There's 4 regions we can possibly shade, but only one of them is going to have the solutions. So the method that I like to use is a test point. Now we're going to test 0, 0. If 0, 0, the x value is 0 on that point, the y value is 0. If we plug those values into these inequalities and 0, 0 works for both of them, then that means we shade this region. And those points in that shaded region are solutions to the system of inequalities. If it doesn't work, we have to choose another test point in one of these other regions. So I'm going to choose 0, 0. What that means is I'm going to plug in 0 for y in the top equation and 0 for x. And I'll do the same thing in the bottom equation. And we're going to see if the inequalities work. So in the left equation, we get 0 is less than 2. That works. That's correct. 0 is less than 2. But in this equation, we get -1 is less than or equal to -6. Well, that's not correct. So what that means is, because the inequalities, one of them doesn't work, we're not going to shade in this region over here. So let's try 0, 4. 0, 4. That would be here. You see that point? So if that works, then we're going to shade in this region. If it doesn't work in the inequalities, then we're not going to shade in that region. So 0, 4, that means plug in 4 for y and 0 for x. 4 for y and 0 for x. Now we're going to simplify those inequalities. So we get 4 is less than 2. Well, immediately we know that that's not going to work. 4 is not less than 2. So that means that this top region here, we're not going to shade in. Let's try 0, -10. 0, -10 is all the way down here, but I know it's going to be representative of this region here. 0, -10. We could also try -2, -3. But I like to stay away from those lines, far away from those lines. So if you choose this point, that's pretty far from that line. So 0, -10. So y is -10. X is 0. And let's simplify. So we get -10 is less than 2. That's correct. And over here we get -11 is less than or equal to -6. That works. It works for both of those inequalities. So if it works for both of them, then that means that this region down here that contained that point represents all the solutions to the system of inequalities. Now your shading doesn't have to be perfect, just as long as the person who reads your exam knows that this region here represents all the solutions. So what that means is if you choose any of these points in that shaded region, any point, And you can even choose points on the green line. You cannot choose points on the dotted line because it's y is less than x plus 2, not less than or equal to. But if you choose any of those points, those pink points, and plug in the x value for x in both of these inequalities and the y value for y in both these inequalities, then the inequalities work. So that shaded region represents the solutions to the system of inequalities. If you got that one right, good job. Now, if you forgot how to do that stuff, that's okay. That's why we're doing a practice test. Okay. I want you to try number 2. If you get stuck, that's okay. But go ahead and try number 2, and when you come back, we'll do it together. Okay, we're back. So it says determine if the following equation has one solution, no solution, or infinite solutions. Prove algebraically. Very important that you prove with algebra your answer. So on the left side of the equation, we have negative 5x plus 1. On the right side, we can combine those x's. 2x minus 7x is negative 5x. Now, there's a number of different ways to do this, but I'm going to add 5x to both sides, and the 5x's just, the negative 5x's just cancel out. So add 5x to both sides, these negative 5x's both cancel out, and that's what makes this equation strange, is because the x's just disappeared, and we're left with 1 equals 1. Now, is it true that 1 is equal to 1? Yes. So what that means is it doesn't matter what x value you plug in to this equation. The equation is always going to be true. So the answer is infinite solutions. Now, if you do all that math and you end up with 0 equals 1, well, that's impossible. It doesn't matter what x value you plug in. The equation is never going to be true. So in that case, the answer would be no solutions. So we proved algebraically why there are infinite solutions. So if you got that one right, excellent. Go ahead and try number 3, and when you come back, we'll do it together. All right, we're back. So this is an absolute value equation. And the way that you solve an absolute value equation is by isolating the absolute value expression. Right now, it's not isolated because the 2 and the negative 4 are next to it. So I'm going to add 4 to both sides of the equation. And then I'm going to divide both sides by 2. And at that point, usually what we do is we break it up into 2 equations. We say x over 3 plus 1 is equal to negative 0, or x over 3 plus 1 is equal to positive 0. But negative 0 and positive 0 are the same thing. So we don't really need both of those equations. I guess we can keep them if we want. So we just solve the equation and we get x is equal to negative 3. That's the only value that will work in that equation. So I guess we can kind of just recombine x is equal to negative 3. So if you got that answer, excellent. Okay, try number 4. And when you come back, we'll do it together. All right, we're back. So we have an absolute value inequality. It's more complicated than the previous problem because it's an inequality. When you try to solve an absolute value inequality, first you isolate the absolute value, just like we did in the previous problem. It's not isolated because the 2 is next to it. So I'm going to put the 2 on the other side. Now we have a much simpler equation. I mean, inequality. It's not an equation, it's an inequality. So there's a lot of different situations that we have to remember. If this were a negative number, then it wouldn't matter what x value you plug in. The inequality would always be true. So if this were -2, then the answer would be any real number. Now, if you flip this inequality around so that it was the absolute value of x is less than or equal to -2, and again you change the +2 to a negative, then the answer would be no solution, because there's no x value you could possibly plug in. So there's a lot of different situations. So you want to memorize this this little box here, and I know that that's a lot of stuff to memorize, but you're going to do it because that's the only way. It seems like a really big task to have to memorize all that stuff, but when you actually attempt to do that, I don't care how young you are, you could be 5 years old, it's not going to take you very long to memorize that if you put in some effort. So what is this situation here? Well, when the absolute value is greater than or equal to a positive number, then we break it up into two parts. X is going to be less than or equal to the negative of the number, and then you write an or. X is going to be greater than or equal to the positive of the number. That's just how it works in this particular variation of these type of problems. So that is the algebraic solution. So as you can see, that was pretty easy. But we have to do the graphical solution also. So we draw a number line, and we're going to have dots that are filled in because it's less than or equal to. And whenever you have this situation, you always have to use the word or, and we're going to shade the outside part and the outside part here. So what that means is all numbers less than or equal to -2 will work in this inequality. So for example, if I plug in -3, absolute value of -3 is 3. 3 plus 2 is 5. 5 is greater than 4. If I plug in a number over here, let's say I plug in 100. Absolute value of 100 is 100. 100 plus 2 is 102. That's greater than 4. So again, how are you going to remember? Do we use the word or is it and? That's all stuff you have to memorize. But you can test points. If you plug in a point here, for example, 0, well, that's not going to work in that inequality. So that's part of the answer, so I'm going to rectangle that graph. Okay, so go ahead and try number 5. This is going to be kind of a weird problem because it says do not assume that x is positive. In that situation, we might have to use an absolute value. So if you forget how to do this, that's okay, but see if you can attempt this problem. This is going to be the 4th class that we did going over roots, I believe. So try number 5. When you come back, we'll do it together. Okay, we're back. So if it says do not assume that x is positive, that means that we have to kind of assume that it's negative in order to understand how to do this problem. So remember, when you try to find the root of a number, and it's a variable with an exponent, all you have to do is take the index, and all you have to do is take this exponent and divide it by the index, so we get x to the 5th. And that's really all you have to do. But the problem is, if this number, whatever x is a negative number, this equation may not actually be true. We might get the wrong sign over here. So the first question we have to ask is this number an even number or an odd number? Is the index even or odd? And the answer is it's even. Even is 2, 4, 6, 8, 10. Those are all even numbers. So it is even, which means that we do have to consider possibly writing an absolute value. Now, We then ask, is this number even or odd? And the answer is, it is odd. If this number were even, then we wouldn't have to worry about absolute value symbols. But because this number is odd, this is the situation where we actually have to consider absolute value symbols. Now here's why that is true. The order of operations tells us that you calculate the inside part first. So x to the 30th power, whatever that ends up being, that's our inside part there. So let's assume that x is negative. Raise it to the 30th power. Now, if you take a negative number and raise it to an even power, is your answer going to be positive or negative? For example, if this is -1 and you raise it to the 30th power, do you get a positive 1 or a negative 1? And the answer is you get a positive 1. Now, whenever you take or find the root using this symbol here, whether it's a square root, cube root, fourth root, fifth root, that result is always defined to be positive. That's just the way it's defined. So take a negative number, raise it to the 30th power, you get a positive number. Take the 6th root, and then you should get a positive number. This should be a positive number. So we know for sure that this is a positive number. It should be. But the problem is, if x is negative, then when you write this expression here, you take a negative number, raise it to the 5th power, then you get a negative number. So it didn't work. This equation is not true. So what we have to do is write absolute value symbols. So I know that that's very, very confusing. But here's what you do. You ask yourself, is this index even or odd? If it's odd, you don't have to worry about writing absolute value symbols. If it's even, we have to go to the next step. Then you ask yourself, after simplifying this and getting your x to the 5th, is this exponent even or odd? That's the second step. If it's even, then you don't have to write absolute value symbols. If it's odd, you do have to write absolute value symbols. So if you want to memorize that process, just rewind the video and remember those steps. So that's kind of a confusing problem. I didn't mean to put such a difficult problem at the beginning of the test, but be aware you may have to deal with some of those types of problems. Now, if a problem tells you assume that x is positive, you don't have to worry about absolute values at all. But if it says do not assume that x is positive, you do have to worry about the possibility of an absolute value symbol there. Okay, it says simplify I to the 79th power. So remember, this is the situation where you take the power and you divide by 4. 4 goes into 7 one time. 4 times 1 is 4. 7 minus 4 is 3. Bring down the next number. How many times does 4 go into 39? It goes 9 times. 9 times 4 is 36. Subtract 36 from 39, we get 3. And that is the remainder. The remainder tells us what the answer is going to be. So if the remainder is 1, then the answer is I. If the remainder is 2, then the answer is -1. If the remainder is 3, then the answer is -I. If the remainder is 0, then the answer is 1. So in this case, we have a remainder of 3, so the answer is going to be -I. So if you got that one right, now remember, the reason for that is that I to the first power is I to the second power is -1, I to the third power is -I, and I to the fourth power is 1. So this is the pattern, I, -1, -I, and 1. And then it starts over again. I to the 5th power is I to the 6th power is -1. I to the 7th power is -I. I to the 8th power is 1. And the whole thing just starts over. So it's groupings of 4. So that's why you divide 79 by 4. When we get a remainder of 3, that means in our pattern, we're on the 3rd term. The first term is I, the second term is -1, the third term is -I, and the fourth term is 1. So you have a remainder of 3. 1, 2, 3, so our answer is -I. You can go back and review this if you need to. If the remainder is 0, then we just get 1. If the remainder is 2, it's the answer is -1. If the remainder is 1, our answer is I. So, if you got that right, excellent. Okay, now we're going to do a system of equations. So this problem is asking us to find the value of x, the value of y, and the value of z. Now the first question we need to ask is which method are we going to use? There's 2 methods. There's substitution and there's elimination, sometimes called addition. Remember, we use substitution when there's a variable isolated. That means that there's a variable by itself on one side of the equation. And x in the second equation is by itself on the left side of the equation. There's nothing else around it. So that means we can use substitution. Now, if you're going to use elimination, it's probably good to label these equations with letters, but we're not using elimination, so we don't have to do that. So I'm going to take the first equation and I'm going to rewrite it. Except instead of x, I'm going to write what the second equation tells us that x is equal to. So what I did is I rewrote the top equation, but instead of x, I plugged in what the second equation tells us x is. Now when you're doing a problem like this, you want to go back and check again and again and again to make sure that you wrote all the numbers correctly, because if you make one mistake, then you're going to get the wrong answer. So now we have to simplify this equation. We're going to use the distribution property. 3 times 2y is 6y. 3 times 3z is 9z. 3 times -14 is -42. And then we just rewrite the remaining part of the equation. Now we can combine the y's. 6y plus 2y is 8y. 9z minus z is 8z. And I'm going to add 42 to both sides. So we get 32 on the other side of the equation. Now we're going to divide both sides by 8, and we get y plus z is equal to 4. Okay, so now I'm going to take the third equation and I'm going to rewrite that equation. But again, instead of x, I'm going to write what the second equation tells us x is equal to. So 2y plus 3z minus 14, that's x. Minus y minus z equals -6. So just to be clear, I plugged in what the second equation tells us x is equal to in the third equation. So this equation here, I got it from there, the third equation in the system. So now we're going to do the same thing we did over here. We're just going to simplify. 2y minus y is y. 3z minus z is 2z. And I'm going to add 14 to both sides of the equation. And we get 8. Okay. So now I'm going to combine those two equations to make a system, and it's probably best that you write the y's and the z's so that they're lined up. So just to be clear, I got this equation from there and this equation from there. Now that's a system, so I'm going to write a brace. And now I'm just going to solve that system. Now, at this point, you're probably thinking, this is a lot of work. It is a lot of work, but the good news is the hard part is almost over. So now we've got a system of two equations. And again, there's two basic methods that we can use to solve, substitution or elimination. Now there's no letter that's by itself on one side of the equation, so we're not going to use substitution. If you took this equation and wrote y is equal to 4 minus z, then y is by itself on the left side of the equation. Then you could use substitution. But that's not the form of the top equation. So we're going to use elimination. Now, the easiest method is to go ahead and subtract the purple equation from the yellow equation. But you can also multiply one of these equations by -1. Then you get negative y minus 2z is equal to -8. Then when you add them together, these cancel out. That's another way to do it. But I'm just going to subtract. And it's a good thing that these variables have the same coefficient, in this case 1. Because then we don't have to multiply by some number. So we're going to subtract. Y minus y is 0. Z minus 2z is negative z. And 4 minus 8 is negative 4. So then we get negative z is equal to negative 4. Divide both sides by -1, and we get z is equal to 4. So the hard part is over. Now all we have to do is take this number here and plug it back into one of the previous equations. Now slow down. Slow down. You're not going to take 4 and plug it all the way up into here. Let's use a simpler equation. Let's use one of these equations. For example, we could use the yellow equation. We'll plug in 4 for z. And just to be clear, we got that 4 from there. And maybe I should bring this down so we don't get confused about the order of what we're doing. So y plus z, z is 4, is equal to 4. So I got that 4 from there. And we can see that y must be equal to 0. So that's one of the solutions, and this is one of the solutions. So at this point, now we do have to go to one of the original equations. So I'm going to take that second equation and rewrite it. So x is equal to 2y plus 3z. X is equal to 2y plus 3z. And don't forget the minus 14. Now you could plug in z and y to the first equation or the third equation, but that would require more work. So the second equation is best for this. Now just to be clear, I got the 4 from there, and I got the y or the 0 from there. That's the y value. So x is equal to 2 if you do the math. Actually -2. So if you got those answers, excellent. I'm going to color that green. Now, sometimes the solution of a system of 3 equations is written as a point. So in that case, x is written first, then a comma, then y, then a comma, and then z. That's just traditionally how it's done. So you don't have to do that. but I just want you to be aware that sometimes you'll see the answer written in that way. So we can rectangle that. That'll be part of our answer also. But you can just write the boxes like this. That's fine. I'm going to do it both ways so that you can recognize what that means in future classes. If you got those answers, excellent. If you got stuck, that's okay. I'd be surprised if students didn't get stuck, given that we haven't done systems for a couple weeks, 2 or 3 weeks. All right, go ahead and try number 8, and when you come back, we'll do it together. Okay, we're back. So when you're working with I, the operations are all the same as when you're dealing with regular numbers. So we're going to use distribution. We're going to multiply negative 5i by 2i. Then we're going to multiply negative 5i by 7. That's the distribution property. So negative 5i times 2i is negative 10i squared, because negative 5 times 2 is negative 10, and I times I is I squared. Then we're going to take negative 5i and multiply by 7, and we get negative 35i. Okay, now I squared, remember, the most important characteristic of I is that when you square it, you get negative 1. So this I squared became negative 1. So negative 10 times negative 1 is 10. And then we just rewrite the rest of the expression. And now we have A plus BI. That's A plus BI form. So if you got that answer, good job. Go ahead and try number 9. And when you come back, we'll do it together. All right, we're back. So we have 2 complex numbers that we're combining. So first of all, we don't really need the parentheses on the first expression. But when you're subtracting a sum or a difference of numbers, you have to change all the signs. So this is positive I, so it's going to become negative I. This is negative 7, so it's going to become positive 7. Another way to think about it is you can change this negative symbol to a negative 1, and then you're using the distribution property. Negative 1 times I is negative I. Negative 1 times negative 7 is positive 7. All right, so now we just combine like terms. 2i plus, actually 2i minus I is I. And 6 plus 7 is 13. But it says to write in an A plus BI form. So we need to write the 13 first. So 13 plus I. So if you got that answer, excellent. If you're rusty on this stuff, then that's okay, but we're starting to remember how this stuff works. All right, try number 10. Number 10 is going to be kind of tricky. There's a trick. We have this fraction, and we need to put it in A plus BI form. It certainly doesn't look like that here. So see if you can figure out the trick for number 10. When you come back, we'll do it together. Okay, we're back. So here's what we're going to do. We're going to multiply both sides by 4i plus 2. So it's the exact same expression that you see in the denominator, except instead of minus 2, it's plus 2. And we're using the fundamental principle of fractions, which means that you can multiply the numerator and the denominator by the same number, and it doesn't change the value of the fraction. So we're going to use distribution in the top. I times 4i is 4i squared. I times 2 is 2i. All right, in the bottom we're going to use FOIL. So 4i times 4i, that's f of FOIL, is 16i squared. And then O of FOIL means outsides. 4i times 2 is 8i. And then we're going to do I of FOIL. That's multiply the insides. Negative 2 times 4i is negative 8i. And then the last terms, L of FOIL is negative 2 times 2. That's L on FOIL. Negative 2 times 2 is negative 4. Okay, now this I squared here, you see this yellow I squared there, that's negative 1. Remember, that's the most important characteristic of I. When you square it, you get negative 1. Now in the denominator, we have an I squared also. So that becomes negative 1 also. And these 8i's, they cancel out. 8i minus 8i is 0. So they just disappear. 4 times negative 1 is negative 4. 16 times negative 1 is negative 16. And so we have negative 4 plus 2i over negative 20. So what we did is we got rid of the I in the denominator by doing all that. Now, I know what you're thinking. You're thinking, I don't want to do that. That seems like a lot of work. Well, you're going to be using that trick in upper math in one way or another, in some form. So it's just something that you're going to have to learn. That trick applies to roots also. But notice that we still don't really have the form that we want. It says up here, write in a plus bi form. This doesn't really look like a plus bi form. So what I'm going to do is I'm going to separate it into two fractions. Now, what I did is I took an expression that kind of looks like a polynomial, even though it's technically not a polynomial. You have the sum of a bunch of terms. You're dividing by a monomial. So you take each term and divide it by the monomial. We took negative 4 divided by negative 20, and we took 2i and divided by negative 20. Another way to think about it is you're just taking the fraction and breaking it up into parts, because these fractions have a common denominator. If you add them together, you get this. We just went backwards. Okay, so I'm going to simplify this fraction, and I get 1/5. And if I simplify the other fraction, I get actually let's write it as 1/10 I. That's in the form that they asked us to write it in. Okay, so if you got that answer, excellent. That was kind of a hard one. So if you had trouble with that, that's okay. Now, if you're having trouble with a lot of these problems, again, that's normal. Most students are going to have issues trying to remember this stuff. But that's the reason that we're doing the practice test. You can see that if you just took a test without studying for it, you may not do very well, right? So that's why we have to study for the test. Okay, on to number 11. It says here, rationalize the denominator. This is actually the same type of problem that we just did, except we're dealing with roots rather than complex numbers. So try number 11. When you come back, we'll do it together. Okay, we're back. So what do they mean by rationalize the denominator? That means we have to get rid of the root in the denominator. Remember, we're not allowed to have a root in the denominator of a fraction. So we're going to have to use that same type of trick that we used in the previous problem. Try number 11. If you get stuck, that's okay, but attempt number 11. When you come back, we'll do it together. Okay, we're back. So I'm going to rewrite the fraction. So I'm going to multiply both sides of the fraction by root 2 minus 3. It's the same expression that you see in the denominator, but it's going to be minus 3. So we're using the fundamental principle of fractions. If you multiply both sides of a fraction by the same number, it doesn't change the value of the fraction. Also, it's very important that you write parentheses on these expressions also, or else it's not going to be correct. If you don't write parentheses, it's going to look like we're multiplying -1 by this expression only and not the root 5, or 3 by root 2 minus 3, rather than the whole expression over here. Okay, we're going to have to use FOIL in the numerator and the denominator. So root 5 times root 2 is root 10. Remember, when you have the same type of root, in this case they're all square roots, you can just put what's inside the root together, multiply those. Now we're going to do O of FOIL. Root 5 times -3 is -3 root 5. Insides, -1 times root 2 is -root 2. And the last terms, -1 times -3 is +3. So that's what goes in the numerator. Now we're going to use FOIL again in the denominator. So root 2 times root 2, well, that's just root 4. Root 2 times -3 is -3 root 2. 3 times root 2 is 3 root 2. And 3 times -3 is -9. Again, that's FOIL. F stands for first terms, O stands for outside terms, I stands for inside terms, and L stands for last terms. So just to be clear, first terms, multiply those. Outside terms, multiply those. Inside terms, multiply those. And last terms, multiply those. Okay, so here's where the magic happens. The numerator we can't really do much with, so we'll just rewrite that. And the denominator, we have root 4. What number times itself is equal to 4? Well, that's just 2. These inner parts cancel out, and that's where the magic happens. -3 root 2 plus 3 root 2 is just 0. So we just get 2 minus 9 in the denominator. So we can rewrite the numerator. Again, there's really not much to simplify in the numerator. And then we just combine the terms. 2 minus 9 is -7. And in this case, it doesn't really tell us to write in a particular form. It just says rationalize the denominator. So we can just leave our answer like that. So if you got that one right, excellent. If you had some trouble, again, it's okay. That's a pretty challenging problem, but it gives you an idea of the things you need to study. Go ahead and attempt number 12, and when you come back, we'll do it together. Okay, we're back. It says assume that x is positive, so we don't have to worry about absolute values. Now, remember, root a over b is equal to root a over root b. Well, what if we go backwards? What if we start from here and we go backwards to here? That's going to be the easiest way to do this problem. Now, there's a lot of different ways to do the problem, but that's the easiest way. So I'm going to take this and turn it into one big root. 50x cubed over 2x. So, and the reason you can do that is because these are both square roots. If you had a cube root in the top and a square root in the bottom, for example, it wouldn't work. You can't combine them. So now I'm going to simplify the inside part. 50 divided by 2 is 25. And x cubed divided by x is x squared. Now again, if x If x is negative, we might have to consider writing some absolute values. But again, we're assuming that it's positive. So the square root of 25x squared is just 5x. 5 times 5 is 25, and x times x is x squared. Again, we're asking what number times itself is equal to 25x squared. Well, that's just 5x, because if you multiply 5x by 5x, you get 25x squared. So if you got that answer, excellent. Now, some of you may have tried to multiply both sides by root 2x. That's okay also. If you did that, then you would get square root of 100x to the fourth over 2x. And the square root of 100x to the fourth, well, that would just be 10x squared, because 10 times 10 is 100. X squared times x squared is x to the fourth. And you just divide that and you get 5x. So you get the same answer. All right, so if you did it that way, that's okay. All right, on to number 13. Try number 13. And remember, we're assuming that x is positive, so we don't have to use absolute value symbols. Try 13. When you come back, we'll do it together. All right, we're back. So we're gonna change the form. So remember, the square root of a times b is equal to the square root of a times the square root of b. So I'm going to take this root and change it to square root of 9 times square root of x. And same thing on the other square root. I'm going to change that square root to square root 81 times square root x to the 7th. So when we do that, we get square root of 9 is 3, and the square root of 81 is 9. And I'm going to combine these over here at the left. 8 times 3 is 24. And then 2 times 9 is 18. So I'm going kind of slow here, showing every single step. You don't necessarily have to show every single step. You can skip some if you feel comfortable doing that. Okay, so there's one more thing we have to deal with. We have a perfect square inside there. I know it doesn't seem like it, but we do. So the way we're going to deal with this is we're going to factor. We're going to make it x to the 6th power times x. Isn't that true? That x to the 6th power times x is x to the 7th? You have 6 x's here, and you're multiplying by one more x to make it x to the 7th. And we're just going to use the same rule. Square root of a times b is equal to square root a times square root b. So square root a times square root b. So I broke this square root into two parts. Maybe I'll show that with some highlighter there. So the reason that we did that is we can now find the square root of x to the 6th power. So I'm going to rewrite the first part of the expression. And the square root of x to the 6th, what number times itself is equal to x to the 6th? Well, that's just x cubed, because x cubed times x cubed is x to the 6th. So we have x to the 3rd power times square root of x. Let me underline that. So that became that. So now our final answer is 24x cubed square root of x plus 18x cubed square root of x. So now we have this here. And notice that these are like terms. You have 24 apples plus 18 apples. They're both apples. So 24 plus 18 is 42. So the final answer is 42 x cubed square root of x. And again, we don't have to worry about absolute values because it says in the problem, assume that x is positive. So if you got that one right, excellent. So now we're going to number 14. It says solve by completing the square. So go ahead and attempt 14. When you come back, we'll do it together. All right, we're back. So to complete the square, we take this number and put it on the other side. So subtract 9 from both sides. And remember, if there's a coefficient here, we have to get rid of that coefficient first. But there is no coefficient, so we can just take this number, throw it over here, and then we're going to complete the square. But we need to find that special number. We can't just add any number to both sides of the equation. We have to add the special number that's going to make this a perfect square. So to find that special number, you take the coefficient of x. It's always the coefficient of x. It's never the coefficient here. It's never this number. It's always the coefficient of the x value that has a power of 1. So you take that number and you do two things to it. You divide by 2, which gives us 5. 10 divided by 2 is 5. Then you take 5 and you square it. So you divide by 2 and you square it. So 10 divided by 2 is 5. Then you square it and you get 25. So we're going to add 25 to both sides of the equation. Now you don't have to do this, but I'm going to rewrite just to show some of that work. So we're going to add 25 to both sides of the equation. Now this is a perfect square. What does that mean? Well, it means we can factor it. And these two factors are going to be the same. That means it's a perfect square. But remember, when you're factoring a trinomial, you ask what two numbers multiply to 25, two numbers multiply together to get 25, and those same two numbers, if you add them, you get 10. So what two numbers multiply to 25 and add up to 10? Start with the multiplication, then go to the addition. So the answer is 5. So we write x plus 5 and x plus 5. Because these two factors are the same, it's now a perfect square. Over here, we just subtract 25 minus 9 is 16. Now we can write that in more compact notation that we're used to. X plus 5 times x plus 5 is x plus 5 squared. At this point, we have an equation with a square. So how do we solve that? And by the way, why is this even a better equation to deal with? Well, because there's only one x. Up here we had an x and an x squared. That was very complicated. Now we just have one x. So how do we deal with this? Well, we isolate the square, and fortunately the square is already isolated. Then we square root both sides. And the reason we want to square root both sides is because we can't get to the x unless we get rid of this square first, this 2. Now, one of the most common mistakes that students make in the entire K-12 curriculum and even into college, one of the most common mistakes they make is they forget to write a plus or minus. There's two answers. So on the expression that's in the opposite side of the variable, you always write a plus or minus when you square root in an equation. You don't always write a plus or minus on a square root, but in an equation, when you square root both sides, you need to do that. So what number times itself is equal to 16? What number times itself is equal to 16? The answer is 4. When you square root, that's the opposite of squaring, so it gets rid of the 2. And now we're going to subtract 5 from both sides, so we get plus or minus 4 minus 5 is equal to x. But we can find what those answers are going to be. If this is positive 4, then 4 minus 5, and I guess I'll just write that, 4 minus 5 is equal to negative 1. But we have to write or. If this is negative 4, then we have negative 4 minus 5, which is equal to negative 9. So these are the two solutions. We solved that quadratic equation by completing the square. Now, are you going to use that when you go into science and engineering? And the answer is no, you're not going to complete the square. You're just going to use the quadratic formula, or you're going to factor. But we need to know how to do this so you can understand the concept that was used to actually derive the quadratic formula. So if you got that one right, good job. And again, this shows us how much we're going to have to study to prepare for this exam. Okay, we have another problem where we're supposed to solve by completing the square. Now notice that we're always supposed to get rid of this coefficient in front of the x squared first. So I'm going to divide both sides of the equation by 2. Now you don't have to show this, but I'm going to show it just so you know exactly what's going on. So when you're dividing a polynomial by a monomial, you just divide each term in the polynomial by that monomial. So 2x squared divided by 2 is x squared. Negative 28x divided by 2 is negative 14. And 96 divided by 2 is 48. 0 divided by 2 is 0. All right, so I think we can solve this problem without completing the square. We could factor. That was true of the previous problem also. But the problem doesn't tell us to factor. It says we need to complete the square. So even though we could solve this problem by factoring, in other words, we could go directly to the two sets of parentheses, we need to solve by completing the square. So we divided both sides by 2. We got rid of the coefficient in front of x squared. You must do that first. Now put the 48 on the other side. That's the second step. And the third step is to go ahead and complete the square. In order to complete the square, we have to find that special number that we add to make this a perfect square. You don't have to rewrite this equation, but I'm going to rewrite. Whenever you want to complete the square, you always take this number in front of the x. Not in front of the x squared, not over here. It's always going to be in front of the x to the first power term. You take that number, divide by 2 to get negative 7, and then you square negative 7 to get 49. That gives us the special number. So now I have a perfect square, but I can't just add 49 to one side of the equation. If I add it to one side, I have to add it to the other side also. So negative 48 plus 49 is 1. And like I said, this is a perfect square. So I'm just going to show all the steps here. You don't need to show quite this many steps, but I'm going to show all that stuff there. Now, we can factor that to a perfect square. What two numbers multiply to 49? You multiply two numbers together and you get 49. And if you add them together, you get negative 14. What would those numbers be? If you multiply them together, you get 49. If you add them together, you get negative 7. Well, obviously the answer would be negative 7 and negative 7. Negative 7 times negative 7 is 49. Negative 7 plus negative 7 is negative 14. So now I'm going to combine those into exponent notation or power notation, condensed power notation. And now we have an equation with a square. So we isolate the square, it's already isolated, and then we need to get to the x, so we're going to get rid of that 2. What's the opposite of squaring? The opposite of squaring is square rooting. So I'm going to square root both sides of the equation. And remember, the most common mistake that students make, or one of the most common mistakes, is they forget to write plus or minus on the side opposite the variable. When you square root both sides of an equation, you must do that. So the opposite of squaring is square rooting, so we're left with x minus 7. And what number times itself is equal to 1? Well, that would just be 1. So now we're going to add 7 to both sides, and we get 7 plus or minus 1. Now you can also write plus or minus 1 plus 7. This way or this way, they're the same thing. So don't be confused by that. Okay, so one possible solution is x is equal to 7 plus 1. Another possible solution is x is equal to 7 minus 1. So 7 plus 1 is 8. 7 minus 1 is 6. So those are the two solutions. So if you got those right, excellent. Now you might say, well, I could have factored this up here. I didn't need to do all this stuff. I could just factor that. But you would get a 0 on that problem if you factored, because the problem doesn't tell you to factor. It tells you to complete the square. One of the things that teachers really are strict about is following directions. And in school, if you don't follow the directions, they get really angry. And that's just the way it is when it comes to tests. If you don't do what the test tells you to do, then usually a teacher will just give you a 0. So we have to use the completing the square method, even though the completing the square method is really long. Okay, on to number 16. Go ahead and attempt number 16. When you come back, we'll do it together. Okay, we're back. So the discriminant is the part of the quadratic formula that is under the root. So remember, the quadratic formula is this expression here. And the part that's under the root, b squared minus 4ac, that's the discriminant. So we're going to use that. We don't have to write the quadratic formula, but I'm just showing you where the discriminant comes from. So the discriminant is b squared minus 4ac. Now that's completely useless unless we know what b and a and c are. Well, this is a is 3, b is 5, and c is negative 10. That's just the way it works if your quadratic equation is in the standard form, meaning everything's on the left side and the right side is 0. You could put everything on the right side also, but we prefer a positive coefficient in front of the x squared term. So the discriminant is equal to b squared, b is 5, minus 4 times a is 3, times c, which is negative 10. So just to be clear, that came from there. Well, I guess we don't really need to plug that in. Maybe if I highlight it up here. C came from there, B came from there, and A came from there. So the discriminant is equal to 25 plus 4 times 3 is 12. 12 times 10 is 120. So the discriminant is 145. So what does that tell us? How is that useful? Well, it tells us how many solutions there's going to be to this equation up here, and what type of solutions they're going to be. Are they going to be real solutions, or are they going to be complex solutions, meaning they have imaginary numbers, I. Now, technically, all numbers are complex numbers, so be aware of that. I know that sounds kind of strange, but for this class, we're just going to categorize it separately from real numbers. So if the discriminant is positive, then we have two real solutions. If the discriminant is 0, we have one real solution. If the discriminant is negative, we have two complex solutions. So in this case, the discriminant is positive, so we have two real solutions. So just finding that discriminant told us quite a bit about the solutions. We didn't actually find the solutions because the problem didn't ask us to find the solutions. We just found the discriminant and used it to determine the number and type of solutions. So if you got 16 right, good job. Okay, number 17, we have another system of equations. So go ahead and try 17, and when you come back, we'll do it together. Okay, we're back. Now, I don't see any letter that's isolated, that's by itself on one side of the equation. So that means we're not going to use substitution. We're going to use elimination. Remember, those are the two methods, substitution and elimination. So when you're using elimination, it's useful to label the equation. So what I'm going to do is, let's see, what can we do? We can eliminate x, or we can eliminate y, or we can eliminate z. We can eliminate any one, but I think I'm going to eliminate x. Actually, you know what? I'm going to eliminate y. Never mind. I'm going to eliminate y. So what I'm going to do, and I'm going to use these letters to keep track of what I'm doing. So what I'm going to do is make a new system. The top equation is going to be b, and the bottom equation is going to be 2 times c. So multiplying the bottom equation by 2, we get 8x minus 2y. Actually, you know what? I'm going to multiply by -2. You can multiply by -2, or you can multiply by +2 and just subtract the equation rather than add it. It's up to you. Then we get positive 6z and -16. So now I'm going to add. So -x plus -8x is -9x. These cancel out, that's why we did that. And 2z plus 6z is 8z. And 6 plus -16 is -10. So we're left with that equation, -9x plus 8z is equal to 10. So now what I have to do is I have to combine two different equations and get rid of y, like I did in the first situation here. So I'm going to combine a and c. So I'm going to rewrite a, making again another new system. So I'm going to multiply c by 5, so I'm going to write 5c, and we get 20x minus 5y minus 15z equals 40. So now I'm going to add those equations up, and I get 22x. The y's cancel out, and I get negative 14z and 30. Now we can simplify that equation. So that's a plus 5c, but I'm going to divide by 2. So we get 11x minus 7z is equal to 15. That'll make the numbers a little easier. So now I have this orange equation, and I have the purple equation. I'm going to combine them into one equation. Excuse me, one system of equations. So I have negative 9x plus 8z is equal to negative 10. So I got that from there. And I have 11x minus 7z is equal to 15. I got that equation from there. There's no variable that's isolated, so we're obviously going to have to use elimination. So I'm going to multiply both sides of the top equation by 11, and I get negative 99x plus 88z is equal to negative 110. And I'm going to multiply the bottom equation by 9, so I get 99x minus 63z, and that's going to be 135. So now I can add them together. Maybe I'll call this equation D and equation E. So I multiplied D by 11. I multiplied E by 9. Now I'm going to add those together, and we get 25z. And over here, it looks like we're going to get 25. Divide both sides by 25, and we get z is equal to 1. Now, I know that was a lot of work, but the hard part is over. Now that we know what z is, we can plug it back into one of these simpler equations to find x. So now I'm going to take, maybe I'll take the top equation, and I'll plug in 1 for z. So that came from there. So we have negative 9x plus 8 is equal to negative 10. Subtract 8 from both sides. We get negative 18. Divide both sides by negative 9, and we see x is equal to 2. So x is 2, and now we need to go to the original equations. We can choose any one of them. I think I'll choose the top equation. So I'm going to rewrite that equation. 2x plus 5y plus 5y plus z is equal to negative 10. Now, actually, we don't know what y is, so I'm going to... So we got the 1 from there, and we got the 2 from here, and we're looking for y. So we have 4 plus 5y plus 1 is equal to negative 10. Solve, and we get y is equal to negative 3. That's just basic math. And remember, we oftentimes see solutions of systems of 3 equations as a point. And x traditionally comes first, then y, then z. So if you got that one right, excellent. Okay, let's go to number 18. Is another completing the square problem. So remember, the first thing you want to do is get rid of the coefficient on the x squared term, but there is no coefficient. So we don't have to worry about that. Next step is to take the constant and put it on the other side. And the reason we're doing this is because we're told to use the completing the square method. So we have to. So now we're going to complete the square, which means we're going to add that special number which completes the square to both sides of the equation. And we always use this number to find that special number. Remember, you take this number and divide by 2 and then square it. So if you divide by 2, you get negative 3/2. If you square it, then you get 9/4. So we're going to add 9/4 to both sides. Okay, let's combine these. That's going to be negative 7/4. And this is now a perfect square, which means we can factor it. And what two numbers multiply to 9/4 and add up to negative 3? That's not exactly going to be obvious. But if you remember, if we assume this is a perfect square, which it is, that's how we designed it, these yellow numbers are always going to be the purple number divided by 2. That's something that you can memorize. So you don't have to actually factor it. So the purple number divided by 2. So that means that these numbers are going to be negative 3/2. Okay, so now we get negative 7/4 is equal to x minus 3/2 squared. Now we have an equation with a square. In order to find x, we have to get rid of the square, so we're going to do the opposite of squaring, which is square rooting. Okay. So now the square is going to go away, and we're left with x minus 3/2 is equal to plus or minus the square root of negative 7/4. Now, we have a negative inside the root, so that's going to come out as an I. We can do that later, though. So plus or minus square root negative 7/4 plus 3/2 is equal to x, so we added 3/2 to both sides. Now the negative is always going to come out as an I. Now square root a over b is equal to square root a over square root b. And square root 7, we can't really do anything to that, but square root of 4 is 2. And we can just leave our answer like that. We could combine those into one fraction because they have a common denominator, but that's okay. We can just leave it like that. We don't really have any room left over anyway. So if you got that answer, excellent. Now there's technically two answers there because it says plus or minus, so just be aware of that. And it's probably best that we write the plus or minus in front of the fraction
It's not really that important, but that's typically how you'll see it.
Okay, go ahead and attempt the next problem. And when you come back, we'll do it together. Alright, we're back. So the absolute value is already isolated, so we don't have to worry about doing that. It's by itself on one side of the inequality. So we need to ask ourselves, is the absolute value less than or greater than this number? And the answer is it's obviously less than. So that means that 5x, and this is something you just have to memorize. You have to memorize the situation when it's the absolute value is less than, and when it's greater than, and when this number is negative, and so on and so forth. Those are all things you're just going to have to memorize. So remember, look on this cheat sheet here. But you're not going to be able to have this on the test. So 5x in this situation is going to be greater than negative 10. And, very important that you use the word and when the absolute value is less than something. 5x is less than positive 10. So again, that's just the situation when an absolute value is less than a positive number. So then we're going to divide both sides by 5, and we get x is greater than negative 2, and x is less than positive 2. So that is the answer. But it tells us to find the algebraic solution, which is what we just wrote, but also the graphical solution. So we need to draw a number line. And these are greater than and less than symbols. They're not greater than or equal to symbols, or less than or equal to symbols. So that means that it's going to be an open dot for both of these special numbers. And the solutions are represented by this shaded in region on the number line. Everything between negative 2 and 2, but not equal to negative 2 or 2. So if you got that answer, good job.
Okay, I think we have one more completing the square problem. So remember, the first step is to get rid of that 5. Divide both sides by 5. And I'm going to show that. You don't have to show it. But I'm going to show it just so we know exactly what's happening here. And we get x squared minus 3/5 x plus 8/5 is equal to 0. That was step 1. Now step 2, we're going to put the constant on the other side. And then we're going to complete the square. We have to find the special number. And to do that, we're going to look at this coefficient here. We're going to divide it by 2. If you divide that by 2, you get negative 3/10. And then we're going to square it, and you get 9 over 100. So we're going to add 9 over 100 to both sides. So why is it that when you divide negative 3/2 by 2, you get negative 3/10? Now this is something that you should already know, but remember, when you divide, you change the multiplication and you flip the divisor. Then when you multiply fractions, you just multiply straight across. Negative 3 times 1 is negative 3. 5 times 2 is 10. So that's why you get negative 3/10. Then you square negative 3/10. Negative 3/10 times negative 3/10 is 9/100. Now this is a perfect square. And remember, it's always this number divided by 2, which we just found is negative 3/10. When you factor a perfect square, it's always this coefficient divided by 2. So now I'm going to have to multiply both sides of this equation by 20 to get negative 160/100. And then we're going to add those numbers up, so we get negative 151/100. And we get x minus 3/10 squared. Then we're going to square root both sides of the equation to get rid of the square. And so we get x minus 3/10 is equal to plus or minus. And first of all, the negative is going to come out as an I. And remember, when you're square rooting a fraction, you square root the numerator and you square root the denominator. So square root 100 is 10. So the final answer is going to be x is equal to 3/10 plus or minus I root 151/10. And you could combine those fractions into one, but we don't have enough room anyway, so we can just leave it like that. If you got that answer, excellent. So now we're going to use the quadratic formula to solve this problem here. So the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Now, I know that seems like a scary formula, but remember, if you do the part inside the root quickly in your head, then the rest is easy. But we're going to show our work here, and I want you to show your work. I want you to plug in the numbers, then you can do the math in your head later. So b, well, first of all, let's write what a, b, and c are equal to, just to be clear. So a is negative 1, b is 1, and c is 5. So b is 1, a is negative 1, and c is 5. So just to be clear, we got that a from there, and we got the b from there, and the c came from there. So now all we have to do is simplify. So 1 squared is 1. Negative 4 times negative 1 is positive 4. 4 times 5 is 20. So we get 1 plus 20. In the denominator we have 2 times negative 1, which is negative 2. Alright, so x is equal to negative 1 plus or minus root 21 over negative 2. Now, I'm going to multiply both sides by negative 1 just to make the answers more simple. So, multiply the numerator by negative 1. We're going to have to use a distribution property, so negative 1 times negative 1 is 1. If you multiply a plus or minus term by negative 1, it doesn't change it. Because if this number is negative, you multiply, it becomes positive. Well, that's already represented there. If you multiply a positive by a negative, it becomes negative, but you've already got a negative represented there, so it doesn't really change anything. So we multiplied the numerator by negative 1. We're going to multiply the denominator by negative 1, and that gives us a simpler expression. But if you write this as the answer, I would accept that also. So that's a formula that shows us the solution to every quadratic equation. If you got that right, excellent. Okay, so now we're going to use the quadratic formula again. Go ahead and try number 22. And when you come back, we'll do it together. Okay, we're back. So I'm just going to write the quadratic formula so we remember what exactly we're using to find the answer. And we just have to plug the numbers in. So b is negative 6. Be aware that's going to be a double negative. Be careful. It's a double negative. And we're squaring b again. Or plugging in again, squaring it. A is 4 and c is 9. Let's double check all that. Now, notice I used parentheses when I squared this negative. A lot of students don't do that. A lot of students write negative 6 squared like that. That's not correct. Don't write that. That is not the same thing. Negative 6 squared without parentheses is technically equal to negative 36. Negative 6 squared with parentheses is equal to a positive 36. Negative 36 is not the same thing as positive 36. Now, why is that? Well, that's just the way mathematicians have defined that notation to mean. So that's just the language that they've chosen. Okay, so now we just simplify. We have a double negative, so negative 6 is equal to positive 6. Negative 6 squared is 36. Negative 4 times 4 is negative 16. Negative 16 times 9 is negative 144. 2 times 4 is 8. And 36 minus 144 is negative 108. So as you can see, it looks like we are going to have a complex number as our answer because there's a negative inside the root. So the first thing I'd like to do is pull that negative out and turn it into an I. So that's going to become I 108. There's a lot of different ways you can think about it. Now, 108 has a perfect square inside it, I believe. 108 divided by 4 is 27. 27 also has a perfect square. So let's do a factor tree so we can see exactly what's going on here. So 4 times 27, and don't be afraid to use your calculator. That's 108, but 9 times 3 is 27. Now these two numbers are both perfect squares, so if we combine them, we get another perfect square. So this is really what we're looking for. So we're going to factor 108, and I think we have enough room to show what we're doing here. So we're going to factor that to root 36 times root 3. Remember, we can do that. So 36 just becomes 6. And I think we're not going to really have enough room for that. So that just becomes 6, and the root stays. And there you go. Now typically, the I is written in the middle here, so I'm going to do that. But I'm also going to reduce the fraction. We can divide all these numbers by 2. Now, a lot of times students will try to divide this number and this number by 2, and this number may not be divisible by 2. Don't do that. You have to divide all of the numbers in the numerator, all the terms in the numerator, as well as the denominator, or else it's not going to work. So divide everything by 2, we get 3 plus or minus 3i. Let me write that a little better. Plus or minus 3i root 3 all over 4. And that's going to be our final answer. So if you got that answer, good. Okay, so that's the last quadratic I think that we're going to have. It says simplify and rationalize the denominator. So this is kind of touching on what we were doing before. So there's a lot of different ways we could do this, but I'm going to change this to root 20 over root 45x to the 5th. That's root a over b is equal to root a over root b. That's one of the rules that we learned. Now 20 is 4 times 5, and 45 is 9 times 5. Sorry, this program likes to throw us around. 45 is 9 times 5, and x to the 5th is x to the 4th times x. Isn't that true? X to the 4th times x is x to the 5th. And I'm going to try to write that a little better. Okay, so now we're going to use another property. Root a times b is equal to root a times root b. And the same is true for these. We can just break it up into multiple roots. Root 9 times root 5 times root x to the 4th times root x. And I forgot to write, we can assume that x is positive. We don't have to worry about any absolute value symbols. Sorry, I forgot to write that. Okay, so root 4 is just 2. Root 9 is 3. And square root of x to the 4th is just x squared. So this became x squared, and this became 2. And this became 3. Okay, so we have 2 root 5 over 3x squared, and we can combine these roots. Root 5 times root x is root 5x. So again, we're using the principle root a times b is equal to root a times root b. We're just going backwards. Root a times root b is equal to root a times b. Okay, so you might think, well, at this point we're done. Actually, we're only halfway done. We now have to get rid of the root and the denominator. So I'm going to rewrite. you don't have to show quite so many steps. And I'm going to multiply both sides by root 5x. And in the numerator, I'm going to get 2, and these are both square roots, so we're just going to multiply the insides. 5 times 5x is 25x. And in the bottom, we get 5x times 5x is 25x squared, but that's just a perfect square. So we're left with 2 times root 25x over 3x squared, and the square root of 25x squared is 5x. So let me see if I can find some more room here. I think we just need one more step to get our answer. So we have 2 root 25x over, multiply the bottom, we get 15x cubed. 15x cubed. So I know that was a lot of work, but just keep in mind that you don't have to show every one of those steps. You do have to show a few of those steps, but you don't have to show every one. So if you got that right, excellent. Okay, simplify and rationalize the denominator. Assume that x is a positive number.
So we're going to start by using this principle. Nth root of a times b is equal to the nth root of a times the nth root of b. So n just means that the index can be any number. And that's going to help us to pull out any perfect cubes out of the root. So I'm going to factor 81 to 27 times 3. Why 27? Well, because 27 is a perfect cube. We want to pull that out of the root eventually. Then I'm going to factor x to the 5th to x cubed times x squared. Why did I do it that way? Well, because x cubed is a perfect cube. So now I'm going to use this principle here, and I'm going to break it up into parts. So we have cube root of 27 times the cube root of 3, and the cube root of x cubed times the cube root of x squared. And the cube root of 27 is just 3. We can't do anything with the cube root of 3, but the cube root of x cubed, well, cube root just counteracts the cube. It's the opposite operation, so we just end up with x. And we can't really do anything with the cube root of x squared. So just to be clear, that became that. That stayed that, I guess. I don't really need to show that. And this orange expression became x. So we've pulled out the perfect cube. Now let's simplify things a bit. So we're going to put the 3 and the x together. Just to be clear, I'm going to highlight where they went. And now we're going to go backwards. We're going to take these two expressions here, and we're going to recombine them just to make things easier. So they both are cube roots, so you can just multiply the inner parts. And there we go. So we succeeded in taking out the perfect cubes. And the reason we chose to do it that way is it makes it easier for us to rationalize the denominator. Okay, so now we can't have a root in the denominator. So now we're going to rationalize the denominator. And to do that, we're going to use the fundamental principle of fractions. We need to ask, what do we multiply 3 by to get a perfect cube? Because if we have a perfect cube inside this root, then the root is going to go away. That's what it means to rationalize the denominator. We want to get rid of the root. We also want this to be a perfect cube. So the only thing you can multiply 3 by to get a perfect cube is 9, or at least that's the smallest number, is 9. So I'm going to multiply both sides of this fraction by cube root 9. And what do I multiply x squared by to get a perfect cube? Well, obviously just x. X times x squared is x cubed. That's a perfect cube. So I'm multiplying both sides of the fraction by cube root 9x. So in the numerator, I get 2 cube root 9x. And in the denominator, when you multiply, again, we're going to use this principle up here, but we're going right to left. When you multiply 2 cube roots, you can just put the you can just multiply the inner parts and combine into one root. So now we have, again, multiplying this yellow part here, we have the cube root of 27x cubed. So I just multiplied the inner parts of the yellow cube roots. Okay, so the big question is, who cares? Why do we do that? Well, we're going to find out right now why that helps us to get rid of the root in the denominator. The cube root of 27 is just 3, and the cube root of x cubed is just x. So to demonstrate, let me show you. 3x times 3x times 3x is 27x cubed. So when you're finding the cube root of something, you're asking what number do you multiply by itself and then by itself again to get 27x cubed. Well, obviously the answer is 3x. So we now have 3x times 3x, and our final solution will be 2 cube root 9x over 9x squared, because we multiplied the denominator. So if you got that one right, excellent. Okay, let's go on to number 25.
So we're going to isolate the absolute value, subtract 1 from both sides. And I'm going to show the steps. You don't have to show quite so many steps here, but multiply both sides by -4, and be careful. Be careful. That's the big mistake that students are going to make. One of the big mistakes, when you multiply both sides of an inequality by a negative, or divide both sides of an inequality by a negative, you have to flip the inequality sign. See how I flipped it? It was greater than or equal to, and now it's less than or equal to, because I multiplied both sides by -4. Okay, so now we have a special situation. Look at your cheat sheet here, and I want you to memorize all of these and understand them. This absolute value is less than or equal to a negative number. If that's the case, then there is no solution. There is no number you can possibly plug in for x that's going to make this less than -4, because this has to be positive. when you calculate the absolute value, it has to be positive. The lowest number that you can get is 0, but even 0 is still not less than negative 4. So the answer is no solution. So you can really stop at that point. So if you got that one right, good job.
So that was the class today. If you'd like to take screenshots of the work that we did to help you study for the test or do the practice test for homework, go ahead and do that now. This is screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6. But don't go before you get your homework. Here's the practice test for homework. This is screenshot number 1 and number 2 and number 3 and number 4 and number 5 and number 6. But don't go before you get the answers. Here's the answers. So get that practice test done completely, correctly, neatly, and put it in order in your binder. And remember, this practice test will hopefully ensure that you pass the exam, but it's not going to ensure that you get an A or a B. If you want to get an A or B, you have to go back and look at all the problems that we did. So get that test done, and I'll see you in the next class when we take the test.